So let's shift into a deep dive on the United States water system and the extraordinary drought conditions. According to drought.gov, in June of 2022, 47% of the contiguous U.S. was classified as experiencing moderate to exceptional drought. And this is a graphic from NOAA that shows the different categories of drought from moderate, severe, extreme, and then the dark red being exceptional. And it's said that this is a time of historic mega drought, and it's getting increasingly serious. It's a drought so big that it has eclipsed 1,200 years of climate history. And while the winter season of 2022 into 2023 has brought a lot of moisture, which has really helped some of the immediate part of the problem, it really hasn't solved the systemic challenges that we face and the underlying drought conditions. And while these drought conditions affect all sectors because water is life, it's having direct impacts on electric generation because hydropower is faltering due to a decline in dams, rivers, and reservoirs. And it's also having a huge impact on agriculture. Because of water shortages, it's estimated that there's 400,000 acres of cropland were idled because of a lack of water in 2022, according to the University of California. So, moving from the drought conditions into how we actually consume water. And over the last 100 years, global consumption of fresh water has grown at more than twice the rate of the world's population growth, which has put a lot of pressure on the limited freshwater resources. And we have an ever-increasing population, economic growth, and then also pollution, which is contaminating the water supply. So this is information from USGS and EPA, and it shows the total water withdrawals from 1950 to 2015 by sector. And we want to really create a distinction here between what is water withdrawn and water consumed. Water withdrawn is the total volume of water removed from the source, such as a lake or river, and often a portion of this water is returned to the source and is available to be used again. Water consumed is the amount of water removed for use and not returned to its source. So looking at this graphic, we can see, that really through the 1970s and into the 2000s, we peaked in our total water withdrawals. And since the early 2000s, we've gotten more efficient through all of the strategies and through, a lot of different methods to decrease water consumption. So we've made huge improvements, but we can see that there's two primary categories that are by far the largest consumers and water withdrawals. So in the US, total water withdrawal is 340 billion gallons of water a day, and the total water consumption is 100 billion gallons a day. And agriculture is by far the largest consumer of water, 41% of water withdrawal and 85% of the water consumption. The second is electric power plants for thermoelectric generation, which use 40% of the water withdrawal, yet only 3% of its consumption. And you can see in the graphic above that by focusing on agriculture and thermoelectric generation to really continue to improve upon the significant gains we've made, but we're going to see through agrivoltaic and storage systems how we can radically improve both of these sectors. And there's more information here at the EPA and USGS websites on this incredible report with a lot of detailed information. So looking at the two major categories of irrigation and thermoelectric, we can see there's a big geographic distribution and a striking contrast between the East and the West regions. The East is dominant for thermoelectric generation, and then the West is irrigation dominant. And as we continue to really focus on one of the greatest opportunities of the Western and Southwestern United States, we can see that irrigation, along with thermoelectric generation, is a huge opportunity to create massive efficiencies. So from this USGS report, we can see that we have 58 million acres of irrigated ag land. And if we break that down, we can see that 55% of it, or 34.7 million acres, is sprinkler systems. 38% or 23 million acres is flood or surface irrigation, and then only 8% or 5.49 million acres is micro irrigation. So really looking at the different types of existing irrigated land that we have as an opportunity for a real innovation point. And then looking at the total water flows per day of the United States, from surface water fresh, what is saline water, groundwater, and groundwater saline. And this goes into the public supply, but it really highlights the water flow of fresh water going into irrigation, the 41%, and then the 39% that's going into thermoelectric cooling. And then what we can see in the gray coming off to the right, we can see through irrigation that we lose 36% of all the irrigation water in what is consumed or evaporated. So we can see a huge area of inefficiency in our largest category of water withdrawal. And then when we look at the geographic distribution of groundwater and surface water withdrawals, we also see a really interesting pattern. 5 states, California, Idaho, Arkansas, Montana, and Colorado, account for 54% of the national total of irrigation water withdrawals. So centered right there in the Rocky Mountains and over to California. 17 Western states cumulatively account for 91% of total surface water irrigations and 71% of the total groundwater irrigation withdrawals in the nation. So 9 of the 10 states with the highest irrigation withdrawals are in the Western United States, highlighting this incredible opportunity to create massive efficiency within the West and the Southwest regions. And then looking at thermoelectric generation, whether it's coal, natural gas, or nuclear, we can see that to produce and burn the 1 billion tons of coal that America uses each year, the mining and utility industries have withdrawn historically 55 to 75 trillion gallons of water annually. It's a massive amount of water that goes to the electrical generation system. And yet, through improvements in technology, we've got more efficient. So going dropping to 52 trillion gallons in 2017, the total intensity of U.S. power generation has fell from 15 gallons per kilowatt hour in 2014 to 13 gallons per kilowatt in 2017. So just to highlight that through a proper application of technology, we can make enormous gains in efficiency within this other large sector of water withdrawal. And then looking at each of the categories, coal-fired generation withdraws approximately 21,400 gallons per megawatt hour in 2020. Natural gas, which is more efficient, has a water withdrawal intensity of 2,000, roughly 800 gallons per megawatt hour. And the nuclear generation is even more efficient, using 400 gallons of water per megawatt hour, totaling 320 billion gallons of water for the nuclear power plant electricity generation. And these numbers come from the EPA and the EIA. Thank you for taking the time to view this section of the United States Agrivoltaic Energy Storage and EV Microgrid Market Intelligence Analysis. Really deeply hope that you found this really valuable and hopefully inspiring. And if you're not watching the entire section on butterflypower.org, really encourage you to come and see all sections to get the totality of this amazing opportunity. And regardless of what channel you're finding this transmission, would be deeply appreciated if you give it some love, give it a like, and share it with a farmer or a rancher or anyone who's interested in participating in the regenerative transformation our economy, our energy sector, and our environment. Any investors who are looking at an amazing opportunity to transform their capital into the regenerative future. And it's just a deep honor and blessing to be here in this time and to participate in this great work. And we are the butterfly generation. It's time to rise and shine. Time to transform and fly.